Hello everyone, and welcome to my lectures on chemical reaction engineering. And today we are going to discuss about various kinetic models. Let me give you the brief about what are the kinetic models and what is its use. If you want to design any reactor, which is the ultimate aim of learning the chemical reaction engineering, you should know at what speed the product is going to form. In a reactor, example, I am continuously pumping in reactants into the reactor and a reaction is happening, the products are getting formed. Then you have to decide what should be the volume of your reactor, right? Because how much volume is necessary for a given amount of product. And everything depends on the speed of the reaction. The more is the speed of the reaction, A giving B, A is reactant and B is product, more is the speed of reactant A forming B, so you can decide what should be your volume of the reactor. Speed, okay, ultimate aim is to define the speed of the reaction or rate of the reaction. That means how you can justify at what speed the reaction is happening. Is it first order speed or zero order speed or second order speed? Is it a reversible reaction or irreversible reaction? Everything decides the speed of a reaction. So, to decide what speed or what rate the reaction is happening, you need to test against a few models. If the speed of a reaction is matching with that of a zero order reaction, then the reaction speed is zero order speed. If the reaction is matching with that of a first order reaction, then the speed of the reaction is first order speed. Like that, we have many situations will come. Depending upon the situations, whichever may be the speed, which is zero order speed or first order speed or second order speed, we have to use that speed in your reactor while designing the reactor. Okay, that is what the thing is. There are many other ways to define the speed. If you follow my earlier lectures, I have defined the speed with respect to differential analysis. There is one lecture, if you go back to my lectures, and using differential analysis, I have found what order speed it is zero order speed or first order speed. In today's lecture and further lectures, we are going to use integral method of analysis to find out the speed of a reaction or order of a reaction. Okay. In this entire next coming lectures, we are going to use, because you need to have some setup to test the speed of a reaction, that setup is nothing but batch reactor. That means everything is closed, we are putting in some molecules of reactant into the reactor and we start conducting the reaction. So, and there is an advantages for measuring the speed in constant volume batch reactor, because the name itself suggests that the reactor which is rigid, because of the reaction, the volume of the reactor will not change. If the volume of the reactor will not change, it is easy for us to measure the speed of a reaction. Okay? Once you measure the speed of a reaction, you can test with various models. I mean, once you get the reaction data, that means if I put in reactants into the reactor, I start measuring the concentration of A. The concentration of A will be a maximum at the initial, minimum at the final, because A is getting reacted. The speed at which the A is getting reacted, it could be matched with the either zero order, first order, second order. Okay. Once you test whether zero order speed or first order speed, second order speed using integral method of analysis. That is what the whole agenda is, to find out the speed of a reaction using integral method of analysis using a batch reactor. Okay. Once you know the speed, you can design a reactor. And why batch reactor? What is the advantage to measure the speed of a reaction in a batch reactor? So, let us move forward and constant, imagine the rate is defined as I mean, before we go into that, that means the constant volume batch reactor, the volume will not change. That means final volume V, which is equal to initial volume V0. That means before the reaction and after the reaction, the volume of the reactor will not change. Okay, let's keep that in mind. And V is the final volume, V0 is the initial volume. If you remember, the rate is nothing but minus 1 by V into dNA by dt. Na is the moles, T is the time, V is the volume of the reactor. Okay, and that means mole per second per liter. This is what that means. How many moles of A, I mean, is changing every liter of the reactor every second. That means how my concentration is changing, because if this is defines the rate and volume is the constant here, now this 1 by V can go into the derivative, because V is constant here. When V is constant, it can move in and out of the derivative. Now if you plug, I mean, take V into the derivative, then d by dt of Na by V. You know, moles by volume is nothing but the concentration. That means d by dt of Na by V will become dCA by dt. Imagine, that means to measure the speed, we can simply measure the concentration, that is sufficient. That means if you want to measure the rate, you need to see how my concentration is changing with respect to time. That means once we have fed the reactor with the reactants, which is A is my reactant, every time, every 30 seconds or every 5 minutes, every 1 minute, you take out some sample from this batch reactor, measure its concentration and see with respect to time how my concentration is reducing. That is sufficient to measure the speed of a reaction, which is minus Ra. Whether it is a first order speed and second order speed, that we can be decided by the models in the integral method. So what happens if you measure the speed using variable volume batch reactor? See, it's simple, the concentration is sufficient to measure the speed, but if you conduct the same reaction in a variable volume batch reactor, because the volume will change because of the reaction, okay, especially gas. So liquid volume will not change. Today we are talking about I mean in general, and volume changes happens for the reactions in the gaseous phase, as I discussed earlier in my previous lectures. Because initial volume before the reaction, for example, is V0, after the reaction more moles got formed and the final volume is V. That you can see the volume is changing here. More is the reaction, more is the volume. Okay. If you see this kind of expansions and contractions of the volume, then let us see in such cases how my speed of the reaction can be defined. I know Ra equal to minus 1 by V into dNA by dt. This is the definition of the speed of the reaction or rate of the reaction. That means now you can see volume, because of volume is changing because of the reaction. Now volume is not a constant. When it is not a constant, you cannot take into the derivative. Instead, you know what is moles? That is nothing but concentration into volume, you get the moles. You replace Na with the Ca into V. Now d by dt of Ca into V, that you, because of the reaction concentration is changing, because of the reaction volume is also changing. That is why none of the terms can come out of the derivative. So d by dt of u into uv derivative you have to apply here. That means I mean V into u derivative plus u into v derivative. That means V into dCA by dt plus Ca into dV by dt. If you take V into the bracket, minus Ra equal to minus dCA by dt minus Ca by V into dV by dt. Here you can see only dCA by dt has come. That means measuring concentration is sufficient to find out the speed of the reaction. Here you have to measure the concentration with respect to time and the volume change with respect to time. That means you need to have two informations to measure the speed of the reaction. That is why people generally go with the measuring the speed of the reactions using constant volume batch reactor. That is why because it is very simple for us to measure. So, in the forthcoming lectures, we are going to use only batch reactor to find out the speed of the reaction, whether it is 0 order, first order, second order, any order speed, we are going to measure only with the batch reactor, constant volume batch reactor. So, what is, because to measure the speed of the reaction, the many scenarios and situations will come. As I told you, it is an integral method. Okay. First, we do not know, by measuring the simple speed, we cannot define whether it is a 0 order speed or first order speed or second order speed. We have to assume the different situations, equations will come and fit, because I know what information I can able to know experimentally. I know at 0 seconds what is my concentration, 10 seconds what is my concentration, 20 seconds what is my concentration. This is the information you get from the experiments. Now you have to fit this experimental data with the assumed models and listed here. Which one fits? I mean, it's a 0 order, first order, second order. So, based on that, we can come to one judgment whether 0 order is best, first order or second order reaction. These are the things we have to work on. So, I know this data, we will see the different situations. What is the, because ultimate agenda is to find out the speed of a reaction. As long as you do not know the speed of a reaction, you cannot design what volume reactor required for the reaction, whether 1 liter volume is required, 2 liter volume is required, 3 liter volume required, and based on that you can design a reactor. So, the first situation we are going to discuss in the next subsequent lectures, 0 order. What is 0 order? Minus RA, as I know, I have defined the order is the sum of the powers of the concentrations in rate equation. And if minus RA minus dCA by, if I is equal to K, that means K is nothing but Ca power 0. That means it is a 0 order reaction. Irrespective of A plus B gives rise to C or A give any reaction, it does not matter. For the rate equation, if this only equation fits, that means it does not matter is A plus B gives rise to C or A gives rise to C. Always minus dCA by dt is equal to K only. The rate does not depend on the concentration. That means the speed of the reaction is the same. That means what is dCA by dt is nothing but speed of a reaction. How my concentration is dropping with respect to time, how fast my concentration of A is getting dropped. Okay. 0 order is nothing but there is no change in the speed of a reaction. That means first 5 seconds the concentration is reduced to 50 to 40, next 5 seconds 40 to 30, next 5 seconds 40 to 30, that means 30 to 20. That means every 5 minutes, example, first 5 minutes 50 to 40, second 5 minutes 40 to 30, third 5 minutes 30 to 20. That means with the time the speed is not changing everywhere. 50 to 40 means 10, 10 to 30 10, 40 to 30 10, 30 to 20 10, everywhere the speed is the same. That is what the 0 order reaction is. Okay. Let us do that. And second we will discuss about the first order, then rate is equal to minus dCA by dt is equal to K into Ca. Because the concentration power is 1, it comes under the first order. What is, how you can visualize this? The speed depends on the concentration. That means more is the concentration, more is the speed. Less is the concentration, less is the speed. 0 order, everywhere the speed is the same. In second order, more is the concentration, more is the speed, less is the concentration, less is the speed. That is why if you conduct a reaction in a batch reactor, initially the concentration of A is more. Okay. So, the speed at the beginning is more. As the reaction proceeds, the concentration of A will drop, so that the speed is also drops. So, now you can see now the speed depends on concentrations, right. More is the concentration, more is the speed, less is the concentration, less is the speed. That is what the first order, second order, everything depends on the concentration. Second order, the third case we will discuss about the second order unimolecular reaction. Second order means power 2 आना चाहिए, you have to get power 2. Unimolecular means, second order means only 2 times A gives rise to B, only one molecule is reacting with another same molecule colliding to form B. It is called second order unimolecular reaction. That means Ra is equal to minus dCA by dt is equal to K into Ca square, that is square, that means 2 times 2, the stoichiometric coefficient of A is 2, okay. And same second order bimolecular reaction, that means A has to react with a B to form C, okay. Minus Ra is equal to minus dCA by dt is equal to K Ca into Cb, because there are 2 things are involved here, okay. Ca power 1, Cb power 1. That means it is also second order reaction, but it is a bimolecular reaction, it is a unimolecular reaction. And the nth order, that means it does not matter what the, it is a empirical kind of equation. When you cannot exactly define what kind of order of the reaction, go for the nth order, okay. Minus Ra is equal to minus dCA by dt, it is equal to Ca power n. From the experiments you get the order n, it would be fraction, it could be negative, it could, fraction, positive, it could be 1.5, it could be 1.3, it could be anything. So that is what, when you cannot exactly define what order, then you get the nth order. N could be, n varies from negative, fraction, positive, anything that comes in play. Next important is reaction series. Not every reaction is a single step. There are multiple steps in a reaction. Series reaction means first A molecule will form R molecule can form S. The product could be R and S, both are our product only, okay. Then if A is reacting to form R with a rate constant K1, when R is reacting to form S with rate constant K2, that is what is given here. A gives rise to R with rate constant K1, R gives rise to S with rate constant K2. Then here sometimes you have, this is your product, S is your product, that means you have to maximize this S, okay. Sometimes R is your product, that means A first forms R, next forms S, but what important thing is R, once R is been formed, immediately S will also form. So somehow you have to maximize the R, because R is our product, S is not your product. So at what cases you get the maximum concentration of R and minimum concentration of S, because that is what the maximize the R here. That is what the complications come in reactions in series, okay. That is why if this is your 2 reactions, disappearance of A minus A, always disappearance we denote with minus, okay. Disappearance of A minus Ra equal to minus dCA by dt is equal to K1 into Ca, because A is only there in the first reaction. So there is only one term that comes in, okay, first order, because the stoichiometric coefficient is 1 here, this is also 1, this is also 1. So minus Ra equal to minus dCA by dt is equal to K1 into Ca, whereas if you talk about R, okay, from first reaction R is forming, second reaction R is decomposing. So if R is your product, then rate of formation of R is nothing but RR, okay, rate of formation of R, okay. Here disappearance, that is the, we have given minus symbol. Here because of the 2 reactions, somehow we have to, if R is our product, we have to maximize the production of R. If R is the our rate of formation of R, so among these 2 reactions, the first reaction is helping formation of R, second reaction is decomposing the formation of R. That means the first reaction is a positive reaction for R, second reaction is a negative reaction for R. That is why formation of R is nothing but dCr by dt. The formation of R, the first reaction is K1 into Ca minus K2 into Cr, minus, because in the second reaction R is decomposing. If I talk about formation of R, then first one talks about the formations, net rate of formation. Normally it is called net formation of R, okay. The first reaction is helping, second reaction is not helping. So which one is helping, that is positive, and which one is decomposing, which is negative, okay. Somehow we get, so these are the things we are going to discuss at that position. And the other category is reaction in parallel, okay, reactions in parallel. That means there are two reactions simultaneously going. A is forming R as well as A is forming S. Okay. A is forming R and A is forming S. Then then there are two things that happens. Okay. Decomposition of A, that is minus Ra is equal to minus dCA by dt, is nothing but first reaction is K1 into Ca plus second reaction is K2 into Ca, because there are two parallel reactions that happens. Here only when you talk about here any reaction only Kca, because there is one decomposing reaction. Here there are two decomposing reactions, A gives rise to R and A gives rise to S. That is why minus Ra is equal to minus dCA by dt. The first reaction is K1Ca plus second reaction plus K2Ca. That is called net decomposition or disappearance of A. Okay. Net disappearance of A because of these two reactions. That is why minus Ra minus dCA by dt is equal to K1Ca plus K2Ca. And the last one we are discussing about the reversible reactions. All this, it is a irreversible reaction. That means final initial point is 100% A, final point is 0% A. Whereas in the reversible reactions, initial point is 100% A, final point is not 0% A, somewhere in between the reaction stops, because there is one reaction is trying to form B and the second reaction from trying to form A. That means one is A is trying to form B and the second reaction B is trying to form A. At one point of time there is no change. That means there is some amount of B will be there, there is some amount of A will be there. So A cannot go to 100%. So those kind of things are called reversible reactions. In such cases minus Ra is equal to minus dCA by dt. One is, which one is decomposing reaction? A gives rise to P, that is why positive K1 into Ca, and the second reaction is trying to form A, that is why it is called minus K2 into Cb. Okay, decompositions we have to keep minus symbol, formations we have the here the, because I have defined in such a way. Disappearance of A is helped by first reaction, that is why it is positive. Decomposition of A is not helping by second reaction, that is why it is K2 into Cb. Here Ra, I am talking about the formation. Formation of A is helped by the first reaction. I mean formation of R is helped by the first reaction, that is why it is positive. Formation of R, it is not helped by the second reaction, that is why it is negative. So these are the things you have to keep in mind before you approach a problem, otherwise you always be in a confusion state when to put positive and when to put negative. Okay. I hope you have learned what are the different things that comes in kinetic, testing the kinetic theory, testing the integral method. And thank you, and let us meet you soon in the next lecture.